They only had 5 employees, including Bill Kimball. Nick Satchuk had left. He wanted to stay small. Bill Kimball wanted to grow. So I decided to open up my own division. And because I was located in Danbury, 2 hours away from Stanford, I basically started. When I got to 3 or 4 employees, we rented a 2,000 square foot office space. We had very little money, but we had big dreams. I would not recommend bootstrap financing anybody. So when you take your product and you want to go to market with it, arrange some financing. Try and do it by bootstrap. It's very, very difficult. And the odds of succeeding are probably less than 1 in 100, 1 in 200. Okay? Much better off. If I had my MBA back then, I probably would have come up with a business plan and not got a bootstrap. When I hired my 4th employee, as I say, we moved to a 2,000 square foot office in Brookfield in 1975. We bought the building, and by 1978, we started a company called Advanced Animations. We made fuzzy creatures that sang and danced, and along with the audio systems and the lighting systems. And we installed those all around the United States and around the world. Brazil, Australia, Italy. And in '82, we sold it to Warner Communications. They bought out the whole kit and caboodle. And in 4 short years, we went to over $10 million a year. Once we sold that division, and I returned full-time to Kimchuck, we decided that we didn't want to start off any more ancillary businesses, that we were going to stick with product design, development, and manufacturing. Now, on the introduction, he says we make prototypes, and we do. But the truth of the matter is the majority of our business is in the manufacturing of the products that we help design and develop for our customers. We have no products in our own portfolio, and we have about 4,500 designs in our archives. Okay? We actively are making anywhere from 350 to 550 products at any one time, different products. Now, in 1986, we outgrew the 25,000 feet that we're in, and we moved to Commerce Park in Danbury, and we now occupy 112,000 square feet with 225 employees. We make all kinds of different products. I'll send you some pictures. I'm going to explain 3 products. One of them is fairly complex, the other one is medium complexity, and the third one is simplistic in itself. Okay? Just to give you an idea of some of the products, I'll pass these pictures along, and if you can pass them out, I'll explain what it all means. This little card on this little red card, the only reason for the printed circuit board is so we don't lose the little red card. The little red card is basically all the different components that we can place, and some of them are small, so small that you can hardly see them. So if you can pass that around, so it's on the little red card there. Okay?
Oh, yeah.
Yeah. Okay, and if you can pass these pictures around, and I'll explain what they are when they come back. One of the most successful products that we've developed is this sniper detection system. And we actually did not do the initial design. It was done by a company called BBN. BBN are the people, they're audio experts. They're now owned by Raytheon. And they're the people that did the 18 minutes of missing tape with Nixon. Also the people that analyzed the tapes on the shooting in Dallas. Okay, so they're audio experts. And this is their solution to detecting an incoming shot. When somebody shoots, there is a shock wave that comes out that's basically a paraboloid. And by measuring the time difference on these microphones, they can figure out where it came from. By measuring the time difference between the acoustic wave, when the acoustic wave finally gets here, they can determine how far away it is. So in 1 second, it tells you how far, how high, and where it came from. Okay? And this is the detection system. It's very ugly. That actually helped them over in Iraq because the snipers stopped shooting at any vehicle initially that had this on it. And the reason was it shot back. And so So this mounted on the vehicle. This is the device that detects it and does the computing. So what we have in here, we have an analog board that takes the microphone, analog microphones in. We convert it over to a digital signal and then send it to here. And then this displays where the shot comes from. It actually shows you a graphic of where it came from, and it screams at you. Okay? Now, when we were originally engaged for this product, on one of these pictures that's going to come around, when Raytheon came to us, they said, this thing works really good on a tabletop, but we don't know how to put it into a package. So can you help us out there? So one of the pictures that you'll see there is a big tin box with a small little display, and that was the original Boomerang. And the truth of the matter is, back in the 90s, BBN had worked on a thing called the Boomerang, but the military never bought it, and that was Boomerang 1. So this next version that you're going to see here is Boomerang 2. And we were engaged to build 50 systems in 45 days, which seemed like an impossible task. We worked 24/7 to do it. We did it strictly on a voluntary basis with our people. Even the moms that worked for us offered to come in at 3 o'clock in the morning if that's what they needed to do to get the next phase done, okay? And we did. We made it in 45 days with 50 systems out. And they went off to Iraq during the heated war, and they worked very well. So once we understood what this product had to do, we told them, if you let us expand the display that's in that picture by 30%, we'll take everything in that big gold box and the display and put it all into this box. And that's what we did. The original Boomerang, this was all metal, all machined. This housing here was $750 to machine it, okay? We designed it in plastic with a very special plastic that's magnetic so that we can withstand RFI EMI, radio frequency interference, electromagnetic interference. So this thing will work even though they got the jammers on. The reason they turn the jammers on is so that by a cell phone or remote control you can't excite an IED. Okay? And this actually works better than the other. And we reduced the cost of this whole system by 50%. And obviously when you see the picture, reduce the size of it phenomenally. We eventually sold 10,000 of these systems. Okay? And one general wrote to us and said, we feel, or he feels, that for every 3 systems that we deployed out into the field, 1 soldier's life per month was saved. Okay? Very, very effective. We had more than a dozen soldiers ask if they could stop by Kimchuk when they were back for R&R, just so they can see where these things are made. And we had one group that had a patrol in Baghdad, and every time they came to a certain part of town, they would get shot at religiously, and they could never figure out where the sniper was because of the echoes. And then they were late in the game, but they finally got a Boomerang. They made arrangements for a gunship to be a quarter mile off, and they said, when we go through there and that guy shoots, we're going to tell you where he is. And that's exactly what happened. The guy did shoot at him, even though they had this ugly looking thing. They called this the killer octopus. This is what the Iraqis called it. But at any rate, they got shot at. They swore the shot came from over there and it was coming from over there. They knew which building it was. They put the gunship on it and took the building out. And that was the last time they got shot at by that group. Now, the way we did this is we couldn't stop manufacturing. They wanted as many as we could make, as fast as we could make them. So we had 2 teams work. We had one team work on doing this work. Designing plastic instead of all the machined metal. And we had another team doing this work. And they were working in parallel, but really not together. These people finished first, and we were able to get the molds out. And so we took the gold cabinet we have there and put it with this, and it was called the Boomerang 2.5. And we sold maybe 300, 400, 500 of those systems. And it was almost 8 months later, by the time we got this designed and manufactured and qualified, had to go through stringent qualifications. and this would call the Boomerang 3. The customer was so anxious to get product out there that he had us build 200 systems before we even built the first prototype. Not a recommended process. And we bit our nails because there's so many things that can go wrong. You make thousands of decisions. And one of the big things is, this is all sealed because it can't allow sand to get in here. And yet we got a lot of heat in here, and yet no one knew how many watts of heat that we were going to develop. And so we did a very unique thing here. This box doesn't have a bottom to it. The heat sink is actually machined to touch all the components on the boards that have the most power on them, okay, so we can get the heat off. And as it turns out, we made it by 15 degrees. And so we lucked out. And believe me, when you build new products, you really don't want to build 200 at the first. Typically what we like to build is 3 to 5, okay? Now, the other thing that we do though, is if you really need a lot of product, we go out and order all the parts for 200, okay, but only build up 5 until you can prove it out. Because typically, if one thing doesn't work, it's not a catastrophe. In other words, you've got to change a resistor value or capacitor value. It's not a big deal. But you don't go out and buy 200 printed circuit boards. And then actually, there's about 3 or 4 different boards in here. And so you don't go out and buy all of those. But this customer recognized the risk and said, go with it. And we did. Unfortunately, it worked.
Jim?
Yeah.
Question. When you said that the box screams at you, what's communicated?
I'm sorry?
You said the box screams at you.
Oh, yes.
What's communicated?
Well, it's communicating where the shot is. Incoming 600 yards northeast.
Got it, okay.
Okay, and it
Visually
displays it,
tell you.
and it displays it here.
Got it.
Okay?
Okay.
And this is all waterproof. This can stand 6 inches of rain per hour at 60 miles an hour.
So that picks it up and then it's there?
I'm sorry?
Are those different things?
Oh, no. This reports to here.
Okay, that's what I wanted.
So this figures out what this is seeing. Okay. In addition to what you see here, we can also put 2 GPSs on here. Okay. And we can report back to central command on a whole situation awareness. So if there's multiplicity of firing situations, this can report back to a laptop with a map on it and show you where all the firing is coming from. And as I said, the final version is the Boomerang 3 was 50% of the cost of the Boomerang 2. Okay, another life-saving product that we developed, just happen to be 2 of them that gets involved in saving lives. Even though you'd say this one's taking lives, it's really saving lives. Is the swimmer detection system. And this is a system that the swimmer wears on his head. And the reason for the head is it's about the only part of your body that isn't underwater all the time. Okay, and this is ultrasonic. It's a piezoelectric device in here. The battery in here lasts about a year and a half. Okay, and when you go underwater for a continuous 20 seconds, then a yellow alert comes off on here. And we can put a multiplicity of these up. They're all wireless mesh network. What that means is, if I need 4 of them, I can put 4 in, and it doesn't care. It talks to it. It finds it. Okay? So this is ultrasonics. This comes up through a hydrophone that comes up to one of these. And this reports to the others that are in the area of what's going on. So 20 continuous seconds underwater, and it goes into alarm, yellow alarm for the lifeguard to be aware that there's somebody down there. And if it goes to 30 continuous seconds, then it goes into red, all kinds of alarms go off. Okay? It works in dark water, so it works outdoors, it works in pools. Believe it or not, the most difficult challenge for developing this product wasn't the ultrasonics, it wasn't the mesh network, it wasn't any of that. It was this water detection system here. This was so difficult to develop, we convinced this company to go get a patent on it. And the reason it was difficult was A, wet hair touching the probes caused it to think it was in the water, okay? B, if you break water for a quarter second, half a second, if air got trapped in there, then sees it as being continuously underwater. So we had to design this so that it drops the air, and see if the meniscus of the water, the surface tension of the water, is touching this unit, it causes the same thing, it causes an alarm. So it took us 3 months of 4 different people working on this to finally come up with it. And then, almost like any good invention, the simpler the solution, the more obvious it is. Why did it take you so long to come up with that? But that's always the case. The more complex the problem, the simpler the solution should be if you've got a really good solution. So this is being tested this summer in 8 different places, and the results have been very good. No drownings either.
So is that for the home gym, or is that for like a hotel, or?
No, they came up with a home one. The home one works on your iPhone. The home one is a totally different principle. If the iPhone knows who's there, you have to log it in. iPhone knows who's there. And if all of a sudden their transmission is gone, then you know they're in the water. And for babies, they put them on their wrist. So if the baby falls into the water, they get an immediate run. It doesn't wait. For an adult, again, they wait the 20, 30 seconds. Okay. And that was the toughest thing, is deciding how long should we wait before we declare an alarm. And by the way, this fancy looking thing, this was 3D printed, by the way, in the beginning. This was the whip antennas on the vehicles. When they got stored in the evening, they tied them down, and in the morning they let them go. And they would come up and wipe out microphones. So we had to come up with a way of protecting them. Basically, that's what this is. All right. Now a low-tech problem. First of all, what is an inventor? The process for inventing is very similar to the process for making a business decision. First, you got to define the problem. And you got to spend some time defining what that problem is, because many times you can start solving a problem that isn't the problem. Okay, so defining the problem is a very critical step before you start finding a solution. The second thing is come up with a number of solutions. Come up with alternate solutions, not just one. Think outside the box. You know, just rack your brain for how else can I possibly do this. Okay. The third step is very critical. What is the consequence of each of the solutions that I came up with? Okay, and again, this is very similar to the way you make a business decision. You define the problem, you come up with potential solutions, and then you come up with the consequences of each of those solutions. And that's very critical, because sometimes you might come up with something that sounds like a really good idea, but it's poisonous, or it's expensive, or it's got other problems. So you've got to define the consequences of all of those things. Then you got to go after it, you got to do it, and you got to stick with it. Okay? They claim the MyPillow took 2 years to develop because of all the different things that he wanted it to do. But he defined what he wanted before he spent all that time actually doing it. So, I have a home down in Florida in a flying community called Spruce Creek. And we have a lot of guests there. And in the morning when they got up, they would all proceed from the bedrooms into the kitchen, and right, the first place you come is where the toasters are, and the bread, and the swirls, and the bagels. And by 10 o'clock in the morning, there's butter everywhere. Because every butter dish gets butter on the cover. So my wife says, Jim, if you can come up with all these sophisticated products, can't you come up with a damn butter dish that doesn't get butter on the cover? And there's a place to put the knife so you don't leave the knife down on the counter. So this was our solution. And believe it or not, we just got the patent on it. The first one of these out was in 1856. So I figured the chances of this coming through patenting was going to be small. But these guys make it almost impossible to pick up butter unless you do this. And so I'll just pass that around. So the point being, the inventions don't have to be this complicated. There's many, many things out there that require it. Now, my wife is gonna start marketing that. Okay, I got,
Jim, is that a 3D,
I'm sorry?
is that a 3D,
Well, we did 3D printing in the beginning, and I'm gonna tell you,
but that's not a 3D printing?
no, that's molded. That's the final mold.
That's a final.
But we did, I will say that we had at least 6, 7 versions. Remember, define the problem?
Yes,
And find different ways of coming into it?
yes.
Well, one of the simple ones was, in testing this with people, picking it up and passing it to someone.
Yeah.
And we had to come up with a couple different ways that we tried it,
Mm-hmm.
okay?
Buttercup.
The other funny thing on that is that works great on all knives. The only one it doesn't work great on is a butter knife. Because the butter knife typically is cocked.
Yes.
Yeah,
Okay,
yeah.
it works okay if you put the butter knife on upside down, but not if you lay it down. And so one of the questions was, should we make those stands higher? And we came to the conclusion, no. It works on almost every knife.
What about a round one, because so many of the butter containers are in those round
That's true.
things, you can make
Okay,
one like that
well,
round?
the thing you should know, there's an eastern butter and a western butter. And we didn't know that till we went for the patent. An eastern butter is one